we want to consider the following reaction. It's also provided us the Kc at 100 degrees Celsius. Initially, we only have the reactant, and it tells us how much, and there is no product. We want to find the equilibrium concentrations of each of the product and reactant. Okay, so I notice it gives me the word initially, and then it's also got the word equilibrium. So that's the key there. I know it's going to be a rice. So what do we do with rice? R is the reaction, so I'm going to rewrite that. And then I need to look into the initial concentrations. So what was given to us in the problem? So I've got I and C and E. So initially it said we had this much N2O4. So I'm going to write that down here. 0.0250. And they made sure to tell us that there was no NO2. Now what about the change? Well, it doesn't tell us anything, but we can remember it's going to be X. Remember, we're losing from the reactant. There's only 1 mole of it, so it's minus X. Over here, we have to gain something, so it's going to be plus 2X, right? Because there's a 2 in front of that NO2. I'm going to add straight down for equilibrium, and I'm going to have 0.0250 minus X. And then over here, I'm just going to have 2X. So what do I have to do next? Well, I'm going to have to figure out what is K sub C. So we do K sub C, and we remember this is the products. And anytime I have a coefficient, remember it's a superscript over the reactants. And then I need to plug in the values that I actually have. So for the NO2, I've got 2X, so I'm going to have 2X, that quantity squared, over 0.0250 minus X. So now I need to simplify that, right? Well, I know the value of Kc that was provided in the original equation. So I've got 0.36 equals, now I want to distribute on top. So I'm going to have 4x squared over the same thing, the 0.0250 minus x. So what I want you to do is I want you to pause the video and do the rest of the algebra to get it in 0 equals form. So when you cross multiply and set equal, you should have got the next line. I distributed it through and then I set it equal to 0. So now I need to know what is A. So A is 4, B is 0.36, and C is going to be negative 0.009. Okay, so now all we need to do is what? We need to plug that into the quadratic formula, which remember is minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So again, I want you to try the algebra portion of this problem and go ahead and plug in what we know for a, b, and c and solve for x. So here you can see my steps when I plugged in what a, b, and c were. Now, when we get to this step right here, you may be wondering, well, how come I don't have two answers? Remember, if I have a negative minus a positive, and the positive is larger, I get a positive number. But if I have a negative minus a number, I'm going to get a negative number. So as we've just seen with other ones, the negative one here, that one you're not going to do because you get a negative number and I can't have a negative concentration. So I found this number here. Remember not to round till we get to this step. I want 3 significant digits. That 8's going to tell me to round up, so I'm going to get 0.0204 molar. Now, that's x. Do I have any x's? Well, if I come back here, remember you want to look at equilibrium, so we're looking at this step right here. That's what I need to plug everything into. So I need to find the concentration of N2O4, and that's going to give me 0.0250 minus what I got up here, the 0.0204, and when I do that, I'm going to get 0.02 0.0046 molar. And then for the concentration of just the NO2, we notice it's 2 times X, so it's going to be 2 times that 0.0204, which is going to be what? Well, that's going to be 0.0408 molar. So what are the final answers? The final answers are for the NO204, or N2O4, excuse me, are going to be this one. And then for the NO2, trying to put everything together, is going to be this one.